Good morning, everybody, and welcome back to Next Door NetAdmin. Today, I'm going to walk you through a feature on switching which is not commonly used, and that is SPAN and RSPAN. What is it? Cool, I just spouted something. What is it? SPAN is short for Switched Port Analyzer. This is Cisco-specific terminology. You may see it on other makes of switches as something like port mirroring or port replication. The purpose for this is to take traffic that is flowing through a switch and mirroring or duplicating it to another destination so that you can connect something like Wireshark or another packet analyzer, probably Wireshark, and be able to analyze the traffic that is actually being exchanged between other devices. There are some limitations and caveats to this. I'll mention some of them as we go. I'm most familiar with doing this on Cisco devices because that's what I've worked with the most, and that's what I learned on. That also helps. So I'm going to show you how to set up SPAN and RSPAN and talk a little bit about the differences between those as we go. First thing to note, it is 100% possible to completely lock up a switch doing this. On one instance, a friend of mine and myself got a little cocky, and we went, "Oh, okay, so let's mirror all the traffic on an entire switch, 24 ports of it, and send it all to a single monitoring station." Guess what? 24 ports all trying to funnel into a single port is too much traffic for the switch to handle, and it locked up. If we had left it for half an hour maybe, it might have unlocked itself once it finished processing all the traffic that was suddenly queued up. In our case, we just rebooted it and said, okay, lesson learned, let's not do that again. But it is 100% possible for you to set up a configuration that essentially renders the switch inoperable. By the same token, you are intentionally trying to record information that is being sent on another connection, which means that your destination is just going to be listening and taking in information. You cannot use this port for anything normal while you are doing your port mirroring. That means if you're trying to access something remotely, you can't run an analysis session on the same port that you are using to connect to it remotely. And that's also why I don't have a live system set up here, because I would need to configure an additional connection and cable it up and all the other stuff, and quite frankly I did not think that far ahead, and if I did, I didn't have time to set it up, so my bad. But we're still going to cover the essentials of how to do this, and then if you want to experiment with it, you can. So, differences between SPAN and RSPAN. Conceptually, they're pretty simple. Local SPAN, or just SPAN, mirrors traffic locally on the same switch or switch stack. So if you have 3 switches that are actually running as a stack, thank you Windows Update, go away. If you have 3 switches in an actual stack, then you can mirror traffic from one member of the stack to another member in the stack, and that's fine. Conceptually, it's still the local switch unit, whether it's a physical switch or a stack. And when you do this, you have a few options for the source. You can choose a single interface. You can choose a range of interfaces. If you choose a single interface, that might be a bonded interface where you have multiple physical interfaces running in a single LACP bond, You can select the ether channel port as your source, and you'll copy all the traffic that's coming off that ether channel. You can choose a port that is acting as a VLAN trunk, and you'll copy all the data on all VLANs coming across that trunk line. There is capacity to filter this to only certain VLANs, so it doesn't have to be all VLANs, but by default it would be. You can, if you want, also mirror all traffic on a VLAN. If the switch has a VLAN interface, then you can use that as a source port and use an entire VLAN and mirror all that traffic out to a single destination as well. And you can have multiple SPAN sessions as well. A source can be used in multiple monitoring sessions, but each monitoring session must have a unique destination. You cannot send traffic from multiple monitoring sessions to the same destination. It'd get too confusing. So if you want to have multiple monitoring sessions, you're going to have multiple destinations. That being said, you also have a choice when you're selecting your source. Let's just say that it's a single port. Okay. You can monitor traffic that is being sent into the switch or received by the switch, or you can monitor traffic that is being sent from the switch and received by the client. In this case, we're configuring this from the perspective of the switch, so it's traffic that the switch receives or traffic that the switch sends. Or by default, it'll monitor both. So anything the switch sends or receives, other way around, sends or receives into the switch will be replicated to your monitoring destination, with some exceptions. By default, it's not going to capture layer 2 protocols. Things like LLDP, CDP, any STP traffic, bridge protocol data units, all these sorts of things will not be captured because by default, it's just looking at untagged traffic. Now, you can add additional keywords to capture this additional data, but then your monitoring station is going to have to just deal with the fact that it's getting everything and not just regular traffic. Wireshark is capable of handling it, I'm pretty sure. But just so you know, there's an additional command there. So how do we actually do this? Okay, well, with local span, it's as simple. Let's pretend that we have a switch prompt here and that we're in config mode. That's the wrong place for that. There we go. Let's pretend we're at the global config mode. All you need to do really is type monitor session a number, pick session 1, and then we'll configure a source interface, and I'm just going to say gigabit port 1, enter. Cool. That's configured your source, although of course you do have to make sure that you spell it correctly, otherwise it's not going to work. And when you do the same thing, you can say monitor session 1 destination interface, and I'm going to say that this is going to go to port 48. Done. Simple as that. You have configured monitor session 1. You've selected the source interface gigabit 101, and then you've done monitor session 1 destination interface gigabit 1048. By default, like I said, it'll monitor traffic that's passing both directions. You can make this explicit by saying both. You can also say RX for just traffic that the switch receives inbound, or TX for just traffic that the switch sends outbound. And because this interface can be anything, you can use, port channel 1, port channel 4, if you're doing an ether channel, which could be LACP or anything else like that. You could do interface VLAN 100. You could do that. But in this case, we're just going to stick with your standard gigabit, and we're going to say both. Now, if you want to monitor the layer 2 protocols, CDP, STP, etc., then on your destination interface, you want to add encapsulate, replicate. Is it encapsulate or encapsulation? I'm pretty sure it's encapsulate. Let me just double check that, because I don't want to give you fake information. That would not be good. Where's my encap? Encapsulation, replicate. So yes, that is encapsulation, replicate. And this way, if you have multiple styles of protocol, if it's an ISL trunk versus an 802.1q trunk, you'll see multiple encapsulations on your destination port. Cool. All right, so that's local span. What's it going to look like with RSPAN? Well, first, what is RSPAN? With local span, we're only copying traffic on the same switch or switch stack. RSPAN, remote span, is a way to monitor that when the source and the destination are on different switch units. Now, because of how this is working, you're essentially you're not sending this mirrored traffic to the destination station. You can't. The traffic is actually addressed to another station. And then you're mirroring this and sending it to a destination where it's not actually addressed for it. So if you try to send this traffic normally through the network, it'll never reach that destination. The network is smart enough to know that the address destination is over there, and it's not over here. So in order to do this within the same switch, pretty easy. You just override it and say, well, this port's being used for monitoring. But how do you get multiple switches to see and understand this? Well, what you need is essentially a dedicated VLAN that is only being used for RSPAN, nothing else. And then the switches go, okay, this particular VLAN is doing special rules, and we're just going to pass traffic on this VLAN without trying to switch it to the correct location. It's going on here as is, and we're just doing this. So what does it look like? Well, again, if we're at our global configuration prompt, the first thing you want to do is configure a new VLAN for this. And I'm just going to copy my prompt because that's going to save some time. When you get your config VLAN, you need to enter, you can still do name and all the other things that you would do with a VLAN, but what you really need here is remote span. That's a single command. And then when you are back at your VLAN prompt, you're just going to, exit and drop back to your regular global config. When you tag it as remote span, that means this VLAN is being used for RSPAN. And if you do a show VLAN on your normal exec prompt, you'll have it identified. After all the VLANs are listed, it'll have a section labeled RSPAN, and it'll have this VLAN listed because it's being used as a remote span, an RSPAN. You need to make sure that this VLAN is identified this way on both your source switch and your destination switch, and anything else in between. If you're using something like VTP, you can probably identify it as a remote span VLAN on your server switch, and all your client devices will get that configuration as VTP broadcasts it, and they'll all know this is a remote span VLAN. Normal rules do not apply. After that, the general format of the commands is much the same. Much the same. So you'd go monitor, and again, because you can only have one destination in each session, I'm going to not reuse session 1. I'm going to use something completely different so that you know it's a completely different thing. Obviously, though, if you have not configured local span, you can use whatever session number you want. But I'm going to say monitor session 5, source interface, gigabit 1032. Okay. And I'm going to say both because I want to track both transmitted and received information. Cool. And then I'm going to go monitor session 5, destination remote VLAN 900. Cool. This switch now knows that it is going to mirror the traffic sent and received from port 32, and it's going to dump it into VLAN 900, which is a remote span VLAN, and normal rules don't apply. That's the end of that. On your receiving switch, you'll have something similar. Monitor session 5, source, remote VLAN 900, and then monitor session 5, destination interface, 1024. And I'll do encapsulation replicate as well. Now, when you do that, because your source is an RSPAN VLAN, things might look a little funky. It might not. It all depends on what traffic is being sent through the VLAN. So anything that is on your RSPAN VLAN will essentially broadcast through the entire VLAN, and then one switch somewhere will say, oh, I'm going to take the traffic off of this RSPAN VLAN and send it to a monitoring destination. Cool. That's it. Now, is this something that I expect people to have to need to use particularly frequently? No, I have not needed to use it particularly frequently. And because it really requires a managed switch in order to make it work, there's been instances where I've wanted to use it and simply not been able to because I didn't have managed switches to work with. And that got to be a real nuisance. But provided you have a managed switch in there or multiple managed switches in there, this kind of setup can be used to essentially transparently see what is happening between two stations, whether that's a managed switch and an access point, or a managed switch and a server that is just not apparently responding to the traffic that it should be. It allows you to have transparent replication of the traffic so that it's not being affected by having to install a listening tool like Wireshark. Maybe you don't have administrative access to this machine. Maybe, like I said, it's another device like an access point or a router where actually configuring that sort of dump of the traffic is not possible or very difficult or doable, but then you can't actually get it to another station for fuller analysis. There might be many reasons why you want to do this, but it's very easy to overload your end device. Even with these commands, think about what it looks like when you're copying traffic that is being both sent and received, other direction, sent from the switch and received by the switch. That's two flows of information, all of which has to be received by a single station. And these ports can be full duplex, which means that a gigabit port can send and receive at gigabit speed. Well, that's 2 gigabit worth of traffic. If it's going to a single gigabit workstation that's trying to do the monitoring, you're going to run into problems. So either you need to be relatively sure that your information is going to match the total capability of your destination port. Maybe it's a low capacity device, it's barely used. Okay, fine. Then maybe a single gigabit port is enough. Or it's, 100 megabit device. So even if it's doing 200 megabit because it's full duplex, it's still within the capability of a single gigabit port. Cool. You just need to make sure that you know what you're doing, or take your chances and realize that you might end up with a switch along the way that says, I've got so much traffic I need to offload to this port and I can't really do it. I'm just going to throw my hands up in the air and go, I don't know what to do. When it's not good when a switch goes, I don't know what to do. But for all of that, it's a very powerful capability, and hopefully, even though hopefully you don't need it that often, maybe this can be useful for you. Hopefully it is. If you have thoughts on anything else that you'd like me to talk about, demonstrate, talk about, and explain why it's a thing, feel free to let me know down in the comments section. Otherwise, like I said, hopefully this has been useful for you. Thank you very much for watching. I am your next door netadmin, and we will see you next time.